Hello, everyone. Welcome to the Grade Tools workshop. It's good to see you all here. We are first going to go ahead and start with introducing ourselves.
Hi, this is Federica. I'm a PhD student in statistics.
Hi, my name is Catalina Medina, and I'm also a PhD student in statistics.
And I'm Mina Doji. I'm an assistant professor of teaching in statistics. We're all in the Department of Statistics at the University of California, Irvine. So today I will be talking about what Grade Tools is, and then we'll talk about why we need it. And then Katerina will take over, and she's going to run us through a basic grading example using Grade Tools. Then Federica will take over, and she's going to do a more comprehensive example. And then we'll have time to share some resources, as well as have some time for question and answers. I should also note that during these examples, because this is a workshop, we will actually be showing you unique cases of grading. So to show you the features of Grade Tools. So it might be normally slower than the usual grading process, but our aim is to show the features, while grading is actually a faster process. And throughout the workshop, we are going to keep referring to grading and feedback. When we are actually talking about grades, we are referring to numeric scores. And when we're actually talking about feedback, we are talking about qualitative feedback that's not necessarily score. So let's take a look at overview of a grading process, how we grade in general. So before we start grading, we actually prepare for grading. These tasks might include things like downloading students' files, or it can be things like preparing a rubric. So we're not actually grading at this point, we're just preparing to grade. In the second step of a grading process, we're actually grading and providing students feedback. So this is perhaps the step that we're actually actively grading students' work. But after we are done grading, we're also returning students' grades and also the feedback files. So this is also part of this process. So let's take a look at the second process, second step in the process for grading and providing feedback. So I'll talk a little bit about automated grading tools. So you can think of automated grading tools and feedback tools as essential long lines of if-else statements. And just to give one example is Learn R package in R. So here's an example where students are given some code 1 + 1, and they're asked to change it so that it computes 2 + 2. So this is an automated feedback tool and is a great tool for formative assessments. So what could happen is if a student keeps the code as 1 + 1 and runs the code, perhaps the feedback could be, you have forgotten to change the code, or please change the code, don't leave it as is, and so on. But this is an if-else statement. If student responds this, then the feedback is that, else the feedback is that, and so on. So there are other examples, automated feedback tools as well, but we're not necessarily talking about automated grading tools when we're talking about grade tools. What grade tools essentially is, it's an automated workflow tool. And what do we mean by that? Let's take a look at some of the tasks we do while we grade. So one of the tasks we do is we download student files. For instance, we could be downloading them from GitHub, cloning them, or like a learning management system like Canvas, Moodle, or anything else. So this is just one task where we actually use a different interface. Then we can go ahead and actually try to open each student's file one by one. And this can be a very arduous task, especially if you have hundreds of students in a classroom. And then we would go ahead and go to our grade sheet and find the corresponding student on the grade sheet once we open their file. And then perhaps we would open RStudio or any other view you use for R to evaluate students' work. And then we go ahead back to our grade sheet and assign the score for the work. And then we go ahead and provide feedback to them. This feedback could be, we could be providing it in RStudio, or we could be providing it in GitHub issues, or we could be directly providing it in Canvas. The point here is that there are so many interfaces involved in the grading process. And we can think about this grading process consisting of administrative tasks as well as pedagogical decisions that we make. So for instance, opening and closing files, finding the corresponding student on the grade sheet, entering and storing grades on the grade sheet. is actually quite an administrative task and does not necessarily involve many pedagogical decisions. But when we think about the time where we're actually thinking about students learning and whether they have achieved learning goals, those are the pedagogical decisions that we make. We evaluate students' work, we provide them feedback, and we assign a score to their work as well. So what gradetools package does is it automates the repetitive administrative tasks, such as opening and closing files and so on. And it minimizes switching between interfaces. We try to do all our grading in our studio. And we also try to save time for more meaningful tasks that require pedagogical decisions.
Sorry, Mina. Catalina let me know that you should minimize the video because it covers a little bit the slide.
Oh, I see. I'm sorry.
Thanks.
All right. So the point is that we are trying to automate administrative tasks. But we've talked about administrative tasks and pedagogical decisions as well. So it's not that just the administrative tasks that are automated, but we also try to save time from providing feedback, the pedagogical aspects of it as well. So we are thinking about more open-ended responses from students and more open-ended assignments such as final projects. So let's think about some feedbacks that we could be providing to students. So one example is please adhere to the Tidyverse style guide, which we ask our students to do. It can be a note, not necessarily scored, but we could be repeatedly telling this to students. We could be telling this to any student. All students could be receiving this feedback, and they could be receiving it in any part of the assignment, any question. And then another example is when interpreting the slope coefficient, make sure to use units of measurements. So this can be related to a specific question, but any student could be receiving this feedback. Whereas, thank you for your note mangling. I'm glad you had fun doing the assignment. Is a feedback specific to one student, and it's not specific to any question. And recall our conversation about the p-value during office hours could be a specific response to a specific student for a specific answer to their question. So when we look at these feedback styles, we are actually, even if we are talking about open-ended assignments, there is feedback that we provide to students over and over again. So we're repeatedly giving this feedback. So gradetools actually tries to save time also on this repeated feedback that is relevant to all students and all questions, but also makes room for specific feedback for specific student or for specific question as well. So how do we achieve this in gradetools? We achieve this by shortening feedback, basically. So we want to, for instance, give the student the feedback, please adhere to the Tidyverse style guide. This is the feedback we want the student to see. But when we're grading, we're not going to type all that out. That's going to be time consuming, writing that over and over. So we actually have short prompt code. So as a grader, I would only be entering the prompt code 1 to grade this. But when I'm grading, I would also have a lot of prompt codes, 1, 2, 3. So in order to remember what these prompt codes correspond to, we also have prompt message, code style. So this is a reminder that this is the feedback that the student would be getting. So this is essentially the basic idea behind gradetools. And from now on, Katerina will be taking over for a short demonstration.
Hello. Okay, so I'm going to go ahead and share my screen. And cool. So everyone should be seeing my slides right now. So right now, I just wanted to show how to install gradetools. Currently, you install it from GitHub, and so you could just run this line as long as you already have your DevTools package installed. And it's in the repo Federica Zoe/gradetools. Okay, so what I'm going to do now, I'm going to take us through a basic demo just showing the core functionalities of gradetools, just to show you how easy it is to grade with gradetools and how nice it is. So I'm going to copy this function call. So assist grading is one of our grading functions in gradetools. I'm going to say for right now, don't focus on the arguments. I'm going to show those afterwards and talk about each in detail. Cool. So right now you should be seeing my RStudio. So right now I'm working in a directory that contains a folder with quizzes, a class roster, and a rubric. I'm going to load the package gradetools. And then I just copied and pasted the assist grading call from the slides. So I press enter here, and then we're going to begin the grading process. So first it lets us know about a grading progress log. So gradetools creates this grading progress log when you begin grading, and this log stores all of the data that gradetools needs in order to maintain your grading progress, but it does not directly store grades here. It actually stores the prompt codes you entered, and so someone would need the rubric in order to know exactly what grade corresponds. But gradetools does all this communication behind the scenes. So this is a file you need to maintain, like you need to keep, but you do not want to edit directly. So before grading, it always lets you know what student you're about to grade. Here we're about to grade Mini Dojo, and you can press OK to begin grading, or you can press cancel to stop the grading process. So I'm going to press OK. Cool. So a few things to know. So on the left-hand side, we have the R Markdown student assignment, and notice it automatically opened for us. For right now, we're going to focus on the right. I have my console on the right-hand side because we find this easier when grading with gradetools. And we have the prompting to grade the first question from our rubric from the assignment. So notice a few things here. So if we focus on this first rubric item, and notice there's like 4 rubric items here. So this first one, let's talk about the components. It looks like, so it starts with the prompt code and then colon. And so the prompt code is what we would enter if we want to assign this rubric item. And then it has the prompt message. This is just a concise message to remind us what feedback is associated with this rubric item. It is not the direct message that would be written to the feedback file. And then here it shows us how many points we're going to remove if we assign this rubric item. And right now we're grading on a negative grading scheme. So we take points away for each rubric item we assign. And then also note below, here we have a few additional prompting options. Federica will talk about these later, so in her demo, so I'm not going to talk about them here. Cool, so we can start grading now. So question 1. Here we're talking about simple linear regression. It asks the interpretation of beta 1. So this is a question students could have answered multiple ways. Here it looks like they gave a perfect response. So to grade this, I want to enter the correct rubric item. So that's a prompt code. All I have to enter is 0, and it takes away 0% of the points. So they got a perfect score on this question. So just say 0 and enter, then it moves on to the next question. And so the next question is a graphing question, and we're plotting the relationship between first-year college GPA and high school GPA. This looks great. The only thing is they flipped the axes on the X and Y variables. The response is on the X variable. So we may want to apply this rubric item that X and Y are switched. So that one, the prompt code is 1A. So I'll enter that and press enter, and it just moves right on to the next one. Here they're asked to fit a model, just simple linear regression, and it looks like they did it great. Cool, I'm going to say correct. It does look like they put parentheses around the whole thing, so they're just like printing their fit. That's fine. So here it's a question about assumptions, and it looks like they didn't enter anything. So here we can apply the rubric item 404, answer missing. So that takes away 100% of the points. And then last question. Here they're asked, what is the estimate of the slope, and provide an interpretation of the slope in context. So here the slope, they say the slope is expected change. Okay, so it looks like they didn't identify the estimate of the slope. Instead, they just printed the entire summary of the regression, and their interpretation is not in context. So here we would want to apply 1A to say no slope was identified, and we would also want to apply 2A to say the interpretation was not in context. So to do that, we just use 2 dashes to separate multiple rubric items. So 1A dash dash 2A. Perfect. So now we've graded all the questions for this assignment, and at the end, it'll ask us if we want to provide any general feedback. So there are some general feedback rubric items already in our rubric, and these are general feedback is a feedback message written at the end of a feedback file that is not specific to any question. It's just feedback across the whole assignment. So notice a couple times the student just printed out their output, like here they printed out the model fit, here they just printed out the summary of the model. So something I might want to comment on is this second rubric item here, where it talks about, so here we see it just says, don't just print the output. And the feedback file or feedback message associated with this will have more explanation for why we wouldn't want to just do that. So I'm gonna assign that one. Something else to notice here is general feedback does not have any points associated with it. It's just more of a comment to help the student improve. Cool, so a couple things to notice. I just entered 2, so I finished grading that student. It shows the final grade they received for the assignment. And then it prompts you to grade the next student. So for our purposes, I'm going to end the demo here, and I'm just going to press cancel to stop grading. So it gives us a few messages. It tells us not all students have been graded. We noticed we did not finish grading Federica. We didn't start grading Federica. And so it just lets us know that. And to finish grading, we can just rerun the assist grading function, and it'll pick us right back up at Federica. And then it also tells us that a final grade sheet is created, and that'll contain the grade. And then it also ungraded students will have a score of NA. And then lastly, it tells us that it knitted the feedback file, or so it was trying to knit the feedback file to a specified HTML format. And then it tells you it succeeded. If it didn't succeed, it would just leave it as an R markdown file. If maybe you were trying to knit to a PDF and didn't have that capability. Perfect. So let's look at a couple of things. So we produced a final grade sheet. So I'm going to open that up. So notice here, there's only 3 students in our class. And these first 2 columns contain the name of the student and a student identifier. So these first 2 columns were present in the class roster, and any column present in the class roster will be copied over to the final grade sheet. It shows the grade that the student received on the assignment, and it also shows the grade decomposed by how many points they earned per question. And then, like we said, any ungraded student will have a score of NA. Cool, so I'm going to go ahead and close this. And then something else we might want to look at is the feedback file. So here we can see the feedback that Mine would receive, and we specified it as an HTML file. So some of them she got correct. Here we can see this is where we applied the 2 rubric items because they didn't identify the slope, and then their interpretation was not in context. And so here, remember, for the general feedback, we asked them not to just print the R output, and the feedback associated with that rubric item explain that as statisticians, we want to convey our findings as clearly as possible. Cool. And your feedback can be as extensive as you decide to make it. So now we're going to go back to the slides. Cool. And so also just one thing I forgot to note while grading is that it also automatically closes the assignment after you finish grading. And then if we moved on to Federica, it would have just opened up her assignment to move on to the next one. So we saw just like how easy it is to grade given just basic grading scenario. So here I'm just going to summarize the 3 core functionalities we saw for gradetools. It automatically opened and closed assignment files. It automatically assigns scores and feedback to each assignment given the applied rubric items, the rubric items we selected as a grader, and it stores the grading progress. So in order to do that process, we have to provide it with inputs. We provided it with the roster, rubric, and assignments. And then the outputs we got was a grade sheet, feedback files, and then later on, Federica will talk about how we can create GitHub issues if we would like. So in order to have this automated workflow, it's necessary that there's a few specific formatting things we have to have for the inputs. So that's what I'm going to move on to talking about next. I'm going to be talking about specifically how the roster has to be formatted, how the rubrics have to be formatted, and how the assignments can be saved. So first, formatting the roster. So the roster has minimal requirements. It must contain a column labeled student identifier. And this column can be anything unique to the student. For example, it could just contain their names, it could contain their student IDs, or like we saw on that class roster, is it contains a GitHub username for each student. And this is just how the how gradetools matches the students to the assignments. So now I'm going to talk about assignment and feedback file paths. So what's nice is for gradetools, the grader only has to provide one student identifier, the assignment file path for that one student, and the feedback path where they would like the feedback to be saved for that student. So as arguments, you only have to provide those three things for one student. So that's really nice. So you don't have to provide a vector for all of the students. And then a requirement, though, is that the assignment and feedback file paths must contain the student identifier, and the student identifier must be the only part unique to that. So down below, we can see, so the example student identifier is the single student identifier that we're providing to gradetools. So here it's Catalina Medina. And then example assignment path, in this case, we want to grade 2 assignments per student. We want to grade this proposal.rmd and this readme.md. So note here that the file path has the student identifier present, and it's the only thing unique to this file path. So in order to get to Federica Zoe's file path, all it has to do is it just takes the student identifier from the class roster and it just substitutes them into the assignment file path. Cool. So now I'm going to talk about directory structures that this allows for, and then a directory structure that this does not allow for. So here on the left hand, we see a diagram of just 2 directories, where each directory contains the student submission for a final project, where they each have a proposal and a README file. So this would be a valid directory structure for grading with gradetools, because to get to the proposal, it's final project Catalina Medina / proposal.rmd. And then the only thing different to get to Federica's proposal is you just substitute the student identifier. Awesome. And so this would also allow for, if you just wanted to save all the students into a single file and that their student identifier was present in their file name. An example that would not be valid with gradetools is on this right-hand side. We see this time Catalina Medina's proposal file is within a subfolder named proposal, but Federica Zoe's is not. So this would not be valid because we can't just replace the student identifier to get to Federica Zoe's proposal. So it would consider Federica Zoe's assignment to be missing because it can't find any at the file path it tries. So we talked about these 3 arguments that we have to provide to gradetools. A single student identifier, the assignment paths for that single student, and then where we would like the feedback to be written for that student. Next, I just want to talk about specifically the types of extensions, the type of files that we allow for assignments and for feedback. So note here we have an RMD file, so an R markdown, and then an MD markdown document, and then HTML. So first, I'm going to talk about the possible feedback extensions. So when you specify where you would like the feedback to be saved, you can specify that you would like it to be saved just as a markdown file, an R markdown. So you would have extension RMD. Or if you would like to be knitted to a certain type, you can specify MD for GitHub documents, docx for Word documents, HTML, or PDF. And then, so those are the ones that gradetools can currently knit to. And then for assignment extensions, so types of files that we can actually open and grade with gradetools is anything that opens in RStudio, such as R scripts, R markdown files, MD files, etc. And so it cannot grade a PDF file because that's not something that opens directly in RStudio. If there's any other type of file that I didn't mention that you're curious if gradetools can work with, gradetools just opens files using navigate to file, so you can always just test it with whatever file type you're interested in. Cool. And last thing I'm talking about is rubric formatting. So I know there's like a lot of text on the page. We're mostly going to be talking about the header here and then the first column. So the column names here, we have a column named name, a column total points, prompt code, prompt message, feedback, and points to remove. So this contains all the information for the rubric, and then this is how gradetools does that prompting and saves associated feedback and grading. So each row of the rubric pertains to one rubric item. So here, boxed in blue, are the rubric items for a question. We can see there's 2 rubric items for question 1A. And then we go through and we move on to these purple items on rows 18 and 19. So rubric items with names specified as all questions are rubric items that we see for every single question prompting. So because just saying correct is taking away 0 points, is something that would occur a lot. We have it as an all questions rubric item, so it's always available. And then we also have 404 for answer missing, for if they just left the question blank, they didn't answer it. And so note here that the only difference is for all questions, it deducts a percentage of the total points for that question, because questions can vary in how many points they're worth. Something else to know about points is this final column, points to remove. If we were doing positive grading, so where we want to add points for each assigned rubric item, then this would just say points to add. And lastly, we can also have another rubric item type. If the rubric item name is specified as general feedback, then this is that feedback that we can provide at the end that has no points associated with it. And is not question specific. Cool, so here's just a reminder of the different columns that we have in our in the rubric. And gradetools requires these columns to be exactly named like this. And so we actually have a function to help you create your rubric template. So just like the headers for the CSV rubric file. And that function is create rubric template. And yes, it'll just create the template with these column headers. And then just recall that when you're adding to it, the rubric items, they can be for a single question or component. They can be for all questions, or they can be for general feedback. So we've talked about everything you need to provide for grading with gradetools. I just want to review the assignments for the grading function. This assist grading call is the function we use to grade in our basic grading demo. So you have to provide it the location of the rubric, the location of the class roster, where you would like it to save that grading progress log that we don't touch, but that it maintains our grading progress for us, where we'd like to save the final grade sheet. The only place where grades are actually located will be in the final grade sheet. And then we have to provide it a single student identifier, a single assignment path, and a single, the file path for the assignments for Federico Zoe, and then the single feedback path. And note again that assignment file paths, like we saw, they can be vectors if there's multiple assignments per student, assignment files per student. Cool, so now I'm gonna stop sharing the screen and Federica is going to take over and show you why gradetools rocks, its extra functionality. And don't forget to unmute yourself.
Great. Catalina just showed us what are the main functionalities that gradetools has. So kind of like the minimal things that we wanted gradetools to be able to do. And now I'm going to show you what, if the grader wants to or needs to, other things gradetools can take care of. The first thing that we thought would be important to add as a functionality was the capability of adding new rubric items while grading. This is because especially for open-ended questions, it is often impractical to specify before seeing student assignments all the items that the rubric should have. And so this gives us the capability of populating the rubric as we grade. Next, as Mina noted before, sometimes as we see student submission, we feel like we would like to give them personalized feedback. Gradetools also gives us the capability to do that in an organized way. We also are able to regrade. Sometimes we make grading mistakes. Sometimes we want to give a student some partial credits when they submit an assignment late. And so we have the capability to regrade either all the assignments, but also, which is often what we may want to do, specified questions and specified students. And then finally, for those instructors that are managing their class using GitHub, we also have the capability of taking note of GitHub issues while we grade. And for those instructors that are not using GitHub, basically issues are messages that an owner of a GitHub repo sees that indicates potential directions for improvements or some things to fix. And so in this way, as we see students' mistakes, we can create an issue on GitHub to tell them to fix something. And then after we are done with grading, in order to finalize grading, we need to upload the grade sheet and we need to distribute the feedback files. So currently, gradetools does not give us any additional tool for uploading the grade sheet to our learning management system. And this is because instructors can use a variety of learning management system, and the solution to this tends to be very specific to what is actually adopted. And also, for distributing the feedback, gradetools does not allow us in general to distribute the feedback. It's something that is kind of left up to the grader. But for those assignments that are managed on GitHub, we actually can push the feedback files to GitHub very easily, and we can create the issues that we have taken note of while we graded. So we have made 3 assist grading functions. The first one is the one that Catalina was using before. It requires to specify fewer arguments, so it's kind of more immediate to use. But at the same time, because there are fewer arguments that can be specified, it does not support us to specify what students and what questions we want to grade. And this, for example, may be useful when there are multiple graders that want to split the students that they grade or the questions that they grade. And also assist grading does not allow us to switch on the possibility to create GitHub or to take note of GitHub issues while we grade, and does not allow us to grade teams rather than individual students. Then we have a function assist advanced grading, which allows us to do the first 2 things, but is not meant for team grading. And then we have a final function that has all capabilities, and it's specific for team grading. And this is the function that we are going to use now in this comprehensive demo. So this is the code that I'm going to use. I'm not going to explain you each argument because Catalina already explained most of them. And also a detailed description is available on the website of our package in the vignette that we have created. But I am going to note a couple of things. So here, as Catalina mentioned before, there are some assignments. For example, here we are going to play as we were grading a final project. There are some assignments that may be made of multiple files. And so in this case, the example assignment path points to a README file, a proposal file, and a presentation file. Then we are going to note that instead of specifying an example student identifier, we're specifying an example team identifier, because as I said before, we are going to play as we were grading teams. And so this is the name of an example of the name of a team. And finally, we are switching GitHub issues to true. And these will allow us to have the option to take note of GitHub issues as we grade. So let's go ahead and start this comprehensive demo. So here, just before getting started, I wanted to quickly show you how the roster and how the rubric look like. And so I'm going to read them in. You can notice here that I am working based off a folder that contains the roster and the rubric. And then there is a script where I had the functions for this demonstration. And then here there is a folder that has the team submissions. And so we can read this in. And then let's take a quick look of what the roster looks like. So here we notice that the column student identifier is complemented by a column team identifier. This specifies what team each student is in. So from here we see in this simple demonstration, we have two teams, a team Gamma and a team Poisson. Next, for the rubric, because I wanted to show you how we can populate the rubric as we grade, I've kind of created a minimal rubric that we need for this case. Because there are three parts to this final project, we need to have at least one element, one row for each of these components. And so we have a README, we have one rubric item for README, we have one rubric item for proposal and one rubric item for presentation. This basically tells gradetools how many parts this assignment is made of. And then we have two items that are available for all questions, unfilled and then style needs improvement. So let's go ahead and grade. So we are going to run, we're going to load gradetools, and we're going to run this code snippet. Okay, so as before, the first thing that we're going to see is a message telling us that a file that stores the grading progress is being created. And we wouldn't see this every time that we resume grading, but we see this because this is the first time that we start grading this assignment. So next, we are seeing that we are prompted to grade the first team that appeared in the roster, which is Team Gamma. So on the left, all of the files that are part of Team Gamma submissions have been opened for us. And in the console, we are prompted to start by grading the first component of the assignment that was specified in the rubric, which is the README. So looking into this README, we can see there is a summary and a data source section. In the summary, the team said that they analyzed the association between body mass and flipper length across species of penguins. So this is a concise summary, but maybe we may be okay with it. And then when we look at the data source, we see that they say we use the data set with penguins data, but they did not really specify where they took the data from. And so let's see what items are available currently in the rubric. There is a summary needs improvement, but we said we may be okay with this summary. And then the two items for unfilled and style needs improvement. So this is a case in which we want to add a new rubric item because we know that this mistake is probably something that other teams will do. And so we can do that by typing R, so to create a new rubric item. So if we click R, first of all, we will be prompted to choose a prompt code. So what code we want to kind of use for entering, for applying this rubric item for a submission. And so in this case, for example, we may want to use 2A because this is the README may be seen as having two parts, and this is the first rubric item for the second part. This could be any code really that you want. It does have to start with a number though. And then the prompt message, here we may want to say, for example, missing data citation. And this is for us to remind us what 2A will mean. And next, the feedback that the student will receive. And so here we may say, for example, it is important to provide the source of your data for reproducibility. We still have to enter the points that we want to be removed from this question when a team makes this mistake. And we are reminded that the total points for this question are 2. This was specified in the rubric. So maybe we want to remove 1 point. And so here at the end, we are presented with a summary of the new rubric item that we're going to add if we press OK. And if we notice at this point that there has been any mistake entering the component of the rubric item, we can press cancel and the rubric item won't be added and we can restart the process. In this case, we see that everything looks fine. And so we can press OK. And we will be prompted to regrade where we stopped. So we will be prompted to regrade the README, but notice that now we also can choose the new rubric item that we have added. And at the same time, behind the curtains, the file rubric.csv has been updated to include the new row that we just have requested. And so in this case, we can select 2A and move on to the proposal. So opening the proposal, we realized that this team has left the proposal blank. They did not fill it. So maybe this could be a mistake when they may have completed the proposal, but they may have forgotten to push it on GitHub. Because GitHub, if they have completed locally on their computer, they still would need to push it to GitHub in order for us to be able to see it. Of course, this is unfilled, so we do have an item that we could apply, but this is also an example in which we may want to take note of a GitHub issue, because if we let them, if we let this team know that they might have forgotten to push, then they could still push and we could give them partial credit. With the GitHub issue, they would be notified. They could be notified immediately when we push it. So now we are only taking note of it. So here I pressed I for taking note of a GitHub issue. It's here. We need to type a title because an issue is made of a title and a body. So the first thing that we have to do is the title. So for example, here, proposal left blank. And here we can say, did you forget to push your proposal? If you push a complete proposal, you will receive credit. Okay, and again, we are prompted to restart from where we left. So now we apply the item unfilled and move on. And then finally, we can grade the presentation. Something useful about grading our files within RStudio is that we can actually see the output. So in this case, because this is a presentation, we can knit it. And it will appear in the viewer. So these will allow us to browse through the presentation as we grade. And notice that we didn't have to open another screen and have these on a different screen. We can just have it everything compactly here. So for the purpose of this demonstration, we are not going to grade all the presentation. But the last thing that I wanted to show you is an instance where we may want to provide a personalized feedback message. And so in this case, we see that the team Gamma left the title as final project presentation. And this is something that we had anticipated. And in a rubric, there is an item title not informative, because we actually wanted them to give an informative title to their presentation. And so before applying 1A, we may want to provide a personalized feedback message, maybe giving a suggestion to this team for how they could have named their presentation. This could be done, especially when, for example, you have a small number of teams, and so it becomes doable to leave personalized feedbacks. So here, I'm going to press P, and I can type the personalized feedback here. Giving a good title to your presentation is important. What about ... And so here I'm going to press 1A. For general feedback, maybe we don't want to provide general feedback, so we can quickly press T. And notice that all the files for Team Gamma have been closed for us. We are prompted to grade the next team in the roster, Poisson. We are not going to grade it for time constraints. The same messages that Catalina showed you before have appeared in the console to inform us of what is going on. The last thing that I want to demonstrate is what it means to push to GitHub. And so we are using, recall that before we took note of an issue that we want to create, but there might be times in which we want to push that issue immediately. There might be times in which we want to wait until we have graded all the teams and push all the issues at the same time. And so for these, we have divided the two we have divided the option to push to GitHub into another function that needs to be called by the grader when they want to push something that has been taken note of. And this function also allows to push feedback. So the first 4 arguments are common to the other functions. So you have already kind of been brushed off upon what this means. I want to tell you though that there are these 2 arguments, push feedback and create issues, that allow us to decide whether we want to push the feedback or create the issue. And in this case, we're going to do both. And also there is an argument for team grading, which is required when we are grading teams, which we are required to switch to true when we're grading teams, like in this case. And so I'm going to go ahead and run these. So first, we will be, every time that we call push to GitHub, we will be required to specify a few preferences. And this is because once we have pushed the feedback or once we have created the issue, we cannot undo it with gradetools. So we want to make sure to get your preferences correctly, and they might change for different times that you call this function. And so would you like to push feedback also for assignments that have been partially graded? So say that before, while grading Team Gamma, we had interrupted grading. We had only graded the README, or maybe we had graded the README and the proposal, and then we had stopped there and wanted to wait until the team gives us or pushes their proposal to continue grading. In that case, we would have an assignment that has been partially graded. And the feedback file would still be created only for the parts of the assignment that have been graded. So right now, this is asking, do we want to push those feedback files, the ones that are incomplete? In our case, it is irrelevant because we finished to grade one team and we did not grade other teams. So there are no partially graded assignments. So we can press yes or no. We're going to press yes. And the same preference will have to be specified for creating issues. And again, because there is no partially graded assignment, in this case, it doesn't matter if we press yes or no. The final preference that we need to specify is whether we want to see and confirm an issue before creating it. And this reminds us that we cannot undo the creating issue with GitHub. So if we don't, if we press no here, all the issues will be automatically created on GitHub. Whereas if we push yes, before creating an issue, we will be asked, we will be presented with a summary. And so let's see what happens. One thing to note is that here in the background, we have been, we pushed the file, the feedback file, and a confirmation has appeared. And then here, we can see a summary of the title that we, a summary of the issue that we had taken note of before. And we can see that the gradetools for us has connected the students to this issue that in the roster are linked to Team Gamma. So if we press OK, we will see a confirmation message that the issue has been created if that was successful. So let's look at how this is on GitHub. So here I had the repo ready for Team Gamma. We can see that a feedback file has been pushed. And this is the one that includes the feedback that we have given, including our personalized feedback. And then we can see that an issue has also been created, proposal left blank, and this has our title body, our issue body. And we can see that the 2 students in this team have been tagged to this issue. We would have wanted to make them assignees, but currently GitHub does not support multiple assignees when you have a private repository in an organization. And therefore, because students' work should be private, we cannot actually do it. We can only assign students when they are for an individual assignments. And so the way around it that we found was to tag them so that they would receive a notification of this issue. immediately. So now let's go back to the presentation. Here there is the code that we have used for reference. And then a final feature that we mentioned before that we're not going to see for time constraints is the possibility to regrade. So say that after creating an issue for Team Gamma, they have pushed their proposal and now we see it and we want to regrade it. So in that case, we will want to specify to use assist regrading and specify that the question that we want to regrade is proposal and that the team that we want to regrade is Gamma. And this is a vector. It could have multiple teams and it could have multiple questions as well. So we have basically come to the end of this workshop. I just wanted to thank you so much for coming and for staying until this point. I wanted to show you one last time the grading workflow and how gradetools interacts with the grading workflow and the capacities that it has. I want to acknowledge the two funding institutions that have funded us while working on this project, the NSF and the Hasso-Plattner Institute for Machine Learning and Data Science. In this slide, you will find links to the resources. So a link to our repository on GitHub and a link on to the website of our package, where you can find extensive tutorials. And now I want to leave the floor to Mine to moderate the discussion, and I encourage you to ask any questions that you have.